All right, hi guys. This is chapter 6's solve problems, practice problems. We're going to use the figures from problem 1 in the solve problems section, but we're going to go through a few different types of work using those same values. We're not going to go all the way to C and D because we're just not going to get to that in this class. There's more you can do as far as efficiency goes and assigning positional weights. But we're just going to basically cover the basics here on chapter 6. So this relationship, I talked about this at the end of the lecture over the chapter material, but this relationship of cycle time to operating time to desired output, this formula can be rearranged to solve whatever it is you are trying to figure out. So if you want to know, how much output you could get, and you knew the operating time and you knew the cycle time, you could rearrange these as you see fit in order to fill in the missing one, right? So with this one, the idea is, how long would it take to make 1 unit of whatever it is we produce with a number of tasks going into producing that 1 unit? So in this example, to illustrate that you can see that there's tasks A, B, C, D, E, F, G, H, I, right? So that's 9 different tasks, each taking a certain amount of time to complete. So you've got 0.3 minutes, 0.6 minutes, right? All of these things, which add up to 4.2 minutes total in order to complete all of the tasks. So with this in mind, let me just move these out of the way right now. We'll come back to that. So with this in mind, we can figure out what the amount of time it would take to complete 1 unit could be, worst and best case scenarios. So the minimum that it takes, minimum possible time it could take to create 1 unit is always going to be equal to whichever of the task times, individual task times, is the longest. Okay, so if you look at this chart that they provide you with the 0.3, 0.6, the longest individual tasks is 1.2 minutes. So let's say that I had a bunch of different workstations working on it at the same time. I could potentially complete 1 unit in 1.2 minutes if I had enough people working on it, right? So, because I could do these 2 that take 0.6 minutes in the same amount of time that it takes me to do this task. And then, maybe I could do these 3 at another station and these 3 at another station. So I could potentially get this done in, 1.2 minutes, conceivably, right? Depending on how many workstations I had. So to figure out our cycle time, all we really need to know is what is the longest individual task time, right? And so there's no formula needed here. All I ask you to do in the problem set is just show me where you get this number from. So by hitting equals and then clicking on longest task time, that's all you need to do here. I'm just asking you to show me that you understand that the minimum cycle time is equal to the longest individual task time, okay? For the maximum amount of time in minutes would be, let's say I did all of the tasks all at 1 workstation. Well, I have to do one that takes 0.3 minutes, then 0.4, then 0.6, 0.2. It adds up to 4.2 minutes. So the longest it could take me, assuming that I could go right from one task to another, would be however long the sum of all task times are. So add all the task times together, I get 4.2 minutes, and that would be the longest cycle time that I should expect. All right, simple so far, right? The minimum cycle time is equal to the longest task time. The maximum cycle time is equal to the sum of all tasks. Those are just the same thing. So again, I'm just putting equals and then clicking on the reference from the inputs to show that I know why I'm putting 1.2 here and 4.2 here instead of just typing it in. Now, as far as your output goes, what would be the least number of units I would expect to get done in a day, and what would be the most number of units? So on this one, to start with, I need you to understand that we're flipping minimum maximum on our references. We're going to be referring to the previous section, but we're flipping where we're getting the information from. And so output in units, knowing this relationship of cycle time to operating time to output, if instead of dividing operating time by output to get cycle time, I was to divide operating time by cycle time, then I would get desired output. So, and it could be, we can just replace desired output with output, right? Whether it's it becomes desired output when it's not a known amount already. So, operating time divided by cycle time is going to equal our output. We can rearrange that. So I'm going to take the time we are open in a day, and I'm going to divide it by the time it takes to make 1 unit. The problem is, you got to make sure before you do this that your units of time measurement are the same units, meaning you're not going to be able to divide hours by minutes. You're not going to be able to divide days by hours. They need to be in the same unit of measurement. So you're open for 440 minutes available per day. If I told you you were open for, you know, what would that be? Let's see, 7 hours and 20 minutes. You can't say 7.333 for 7 1/3 hours, right? So this is like an 8-hour day where they're closed for 40 minutes for lunch, maybe. So they need to be in the same unit of measurement. Minutes is what we're talking about. So make sure this is recorded in minutes. If I told you 8 hours a day you're open, you need to have 8 hours times 60 listed here and have it in minutes, right? So 480 minutes in a day. All right, so output in units, this minimum is not going to refer to the minimum here. Why? Because minimum number of units produced is not a good thing. So we're going to be dividing the operating time in a day by the maximum amount of time it would take me to get 1 unit done, because getting a unit done produced slower is associated with worse production levels, which would be a smaller number of units produced. If it takes me longer to produce 1, then I'll get fewer units out in a day. So this minimum number of units needs to refer to this maximum field. 440 minutes divided by 4.2 minutes for cycle time. I would expect the minimum number I could get done in a day would be 104.8 units. Conversely, I'm going to divide the 440 minutes in a day by the 1.2 minutes. Assuming I could get it done faster, I should be able to get more units out, and I get 366.7 units. So these are our minimum and maximum outputs depending on how many workstations we get. So now that we know that, what would the minimum number of workstations I could theoretically get in place, but still be able to maximize the task times here? So we're given 1.2 as our minimum. So how many workstations would I need? Okay, so we would need why do we have, sorry, determine the appropriate cycle time. Okay, so there's a little bit more to this problem. I was wondering why I had 1.6 listed in my right here, and that's because it's not the minimum number of workstations to hit 1.2, because the company says they want to get exactly 275 units in a day. So the minimum I could do is 104. The maximum I could do is 366. Part A asks us to figure out what's the appropriate cycle time to get 275 units in a day. So really, I should have, let me rearrange this real quick. I should be doing this first. There we go. I need to figure out what the appropriate cycle time should be for making exactly 275 units. So I'm going to once again rearrange this value, knowing the relationship between the minutes we're open, operating time, and desired output. Oh, actually, this is the formula I need. Operating time divided by desired output. So 275 is our desired output. 440 is our operating time. So I'm going to take 440 and divide it by 275. So our cycle time should be 1.6 minutes. And this lies between the minimum of 1.2 and the maximum of 4.2. So we know it's a possible cycle time. We could get it done in 1.6. We couldn't get it done in 1 minute, right? So that's why we've done this, to make sure that the desired output is between our minimum and maximum. So 275 is between 104 and 366. So it's possible to get 275 in a day. And cycle time of 1.6 minutes is between our minimum and maximum time that we could take to cycle. So that's very possible as well. Now, how many units, how many workstations would I need if I wanted to get 275 units in a day? So our number of workstations formula is right here. Number of workstations is equal to the sum of all task times divided by the cycle time. So the sum of all task times, this capital letter sigma always means sum. And in this case, the formula is referring to all the task times. We're going to divide it by the cycle time that we have deemed appropriate, which is 1.6. So the sum of all task times is 4.2 minutes. We're going to divide 4.2 by 1.6. So equals 4.2 divided by 1.6. But we get 2.6, and it's actually like 2.625. So this is what we get as our answer there to this part B here. Sum of all task times divided by cycle time, we get 2.6. But we always have to round it up. We need to round up the number of workstations always, because I can't have a partial workstation. I either have a workstation or I don't. Okay. So if I need a partial workstation, 2 point anything other than 2.0 flat is going to round up to 3. 2.1 workstations rounds up to 3. It's not a round to the closest whole number situation. You always round up. So to do that, instead of just writing equals this divided by this, I'm going to use an equals roundup formula at the beginning of my formula. Now, if you want to do this in 2 steps, if you want to do find this here, and then I can't recall actually how I set the thing up on the template, but if you want to do that first and then do equals roundup and click on this, and we're rounding up to the whole nearest whole number, not nearest decimal place. So you hit round up, click on the number, comma 0. 0 is 0 digits. We want a whole number. We'd get 3. So 2.6 rounds up to 3. But I don't have to do that as 2 steps. I can actually do equals roundup. And I can round up 440 divided by 1.6. Oops, comma 0 decimal places. What did I do? Clicked on the wrong one. Oh. Operating time divided by desired output. Oops, I clicked on. Yeah, sorry. I'm looking at formula A. Sum of all task times, 4.2 divided by 1.6. This formula right here. And I get 3. So round up, let's do that one more time. Equals round up. 4.2, sum of all task times divided by cycle time, comma 0. And I get 3. And then this last step I just put in here, let's say that we had a desired cycle time. This is just to show you that if we had a cycle time in mind, we could rearrange it. If I wanted to get one done every 45 minutes, how many units would I get done in a day, right? So I can rearrange it to say 440 minutes in a day and get one done every 45 minutes. I get 9.8 units out in a day. It'd be pretty bad. Why would we want to take 45 minutes to get it done when we can get one done in 4.2? I don't know. But let's say it was 3 minutes, right? If I write that out, I want to get one done every 3 minutes, then I'll get 146 done in a day, right? Your desired cycle time should be, between these 2 numbers, your theoretical minimum maximums. Well, this is the actual minimum. This is you could cycle longer if you don't do your tasks on time. But let's say you wanted to get one done every 2 minutes, right? That was your goal. Get one made every 2 minutes. How many would we get out in a day? 220. You can rearrange, like I said, this to whichever one you're missing. Even if it was operating time, I have to do. I want to get 200 units a day, and it takes me half an hour per unit. How long would I have to stay open to do that, right? You could rearrange it to find that number. All right. So really, that's it. That's the entirety of chapter 6's quantitative work that we're going to be working on. I think I've presented it as one long problem, if I'm recalling right. It's either chapter 6 or chapter 8, that it's just one long multi-part problem instead of, the normal 3 or 4 problems for the chapter. So a little bit of a break after the longer, more quant heavy chapter 5. All right, everyone, we'll see you in chapter 8 in our next chapter in the book. Thanks, everyone.